And then a final thing we can do, and again it seems a bit esoteric but it's worth doing it, is we can look at a universe which is dominated by curvature. That is, that the energy density terms don't matter. So in the Friedmann equation I have A dot over A squared. I don't care about all of the energy density bits, I just care about the Kc squared over R naught squared A squared, i.e. A dot squared is just equal to, there is a minus here, isn't there, minus Kc squared over R naught squared. And so now I want to solve that equation. How can I solve it? Well, I can look at the different values of k. K can be -1, 0, or +1. Just start with k equals 0. To start with, k equals 0, A dot equals 0. So you can have a static, flat, empty universe. Perfectly allowed, not very interesting. You can have k equals 1. But in this case you have no physical solution, because you have imaginary A dot. And for k equals -1, you just have A dot equals plus or minus C over R0. And I can integrate that straightforwardly. Just got dA by dt equals this. So when I integrate this, I just get dA, the integral of dA equals C over R0, the integral of dt. So A of t is just equal to t over t0. So for a negatively curved universe, it just expands, basically free streams forever. And so if I wanted to draw that again, just to put all of these together for the sake of completeness, I have t and I have A of t. I have radiation. That's t to the half. I have matter. And that is t to the 2/3. What shall I use for lambda? Let's use pink lambda. I have the cosmological constant. The cosmological constant is kind of difficult to put on this because the thing about a cosmological constant is an exponential, as I go back and back, never actually goes to 0. So it's actually slightly tricky to plot on here, but this is basically an exponential expansion. There's a better drawing of this in the PDF notes, which plots it against something different. Note the cosmological constant, because it never goes to 0, also means no Big Bang. And then finally, coming through the middle here, I have an empty universe. And there, all of your possibilities, all plotted now in an actual analytical form that tells you how the size of the universe changes with cosmic time.